Okay, welcome to vodcast number 2. This is about solving right triangles using trigonometry. And you may have been wondering, we've been talking about SOHCAHTOA and sine is opposite over hypotenuse and all those kinds of things. I think I'll write that down again for you. Sine of some angle A is equal to the opposite over the hypotenuse. And the cosine of A is equal to the adjacent side over the hypotenuse, and the tangent of angle A is equal to the opposite side over the adjacent side. Okay, so we defined all those things, and then, okay, great. Now what do you do with these things? Well, it's really great for solving for missing parts in a right triangle. So I've got two triangles here. One has a 30-degree angle in it, so we know lots about that. We've been studying that, and we've called that's called a special right triangle. It's really special. And we could solve for x in a number of different ways here, but I want to do it in a particular way. So I could write down that x, the opposite side from the 30-degree angle, over 18, the hypotenuse in this triangle, is equal to, well, that's opposite over hypotenuse. That is the sine of the angle 30 degrees. Well, we happen to know, we've explored in recent things, that the sine of 30 degrees, or maybe the way we said it before, is the short leg in a special right triangle, 30, 60, 90 right triangle over the hypotenuse is equal to 1/2, has a 1:2 ratio. Or another way of saying it is the hypotenuse is twice as big as the short leg. Well, in any case, that is x over 18 equals 1/2. We can solve that. 2x is equal to 18. X is equal to 9, just as we suspected. But, and we can actually look at your calculator, and if we hadn't known that the sine of 30 is equal to 1/2, if we didn't have that special knowledge, we could get out our calculators and take the sine. Have to make sure you're in the right mode, by the way, so check your mode, make sure you're in degree mode, and then take the sine of 30 degrees. Hey, that's 0.5. Great. I could have done that even if I didn't know that the sine of 30 is 1/2, or have that special relationship. So let's go back to this other triangle, which is, every triangle likes to think that it's special, and this one's not quite as special as others, but I can still write down the sine of this angle 40 degrees, the sine of 40 degrees. Actually, let me do it differently. Let me say, now I'm looking at this triangle, I'm trying to figure out how am I going to do this, and I write down, okay, I can write a ratio of the, I know this angle 40 degrees, I can write down a ratio opposite p over 20, p over 20, and I identified p. Okay, p is the opposite 40 degrees, and 20 is the hypotenuse. Okay, so SOHCAHTOA, that is the sine then of 40 degrees. I've clearly identified that. Now, when you do these problems, do the algebra first. And what I mean by that is, instead of going to your calculator right now, do this. Multiply both sides by 20 over 1, 20 over 1 on both sides. And that gives me, 20's cancel out. I'm isolating p. I get p is equal to 20 sine 40. And usually you write that number 20 in front of the sine expression. Those are just two numbers, though. Now I go to my calculator, and I do 20 times the sine of 40 degrees, and that gives me 12.86. P is equal to 12.86. All right, that's the answer. I've just solved that. I could now go and find the other missing side by either using the cosine. Let's call that q over here. I could do q over 20 is equal to the cosine of 40, and go through the same process. Q, I'm going to take a shortcut here. Q is equal to 20 cosine 40, and I can do that on my calculator. 20 cosine 40, get an side, that's 15.32. Q is equal to 15.32. Now it also should be true that P squared plus Q squared should equal 20. Let's check that out. I'm going to be rounding here. We could use stored values and make it more accurate, but 12.86 squared plus 15.32 squared is equal to 400.02. I think that 0.082 is just a round off error because I know the square root of 400 is equal to 20. So hey, I think everything worked out. Now I could have found Q by using the Pythagorean theorem and then checked it by using cosine. So you can, all these things kind of work together, and lots of ways of double checking your answers. Okay, that's one problem. Here's another problem with an added twist. Not too much of a twist, but I look at this triangle and I've got this angle of 57 degrees. I've got an 11 side with a leg with 11 and hypotenuse is x. Okay, so I guess my choice here is to write, I can write a ratio like this. I can't write x over 11 because I don't have any of those ratios that's the hypotenuse over the adjacent. But I do have one that's the adjacent over the hypotenuse, and that's called the cosine. Now the reason I'm doing this example is because sometimes students have difficulty when the variable is in the denominator. And again, I want you to do the algebra first. So I'm going to multiply both sides by x. Because first I want to get rid of the fractions. Okay, so I get 11 on this side, and I get x times the cosine of 57. Now this cosine of 57, it's just a number. It's just like the number 3 or 5 or 7. And if you had an equation that said 11 equals 3x, you would divide both sides by 3. Well, I have an equation that says 11 equals cosine 57 times x. So I'm going to divide by that thing that x is being multiplied by. And I'm going to do that on both sides because that's what I do in algebra. And that gives me that x is equal to 11 divided by the cosine of 57. Okay, I get out my calculator again, clear this junk away. I do the 11 divided by the cosine of 57, and that tells me that the hypotenuse is about 20.2. X is approximately 20.2. Great, that's it. Now I could also find this missing angle. How about what's this angle over here? Now that angle y is equal to 90 minus 57 degrees, and that is equal to whatever 90 minus 57 is. 90 minus 57 is equal to 33 degrees. So I can figure out everything about this triangle. I knew two pieces of information. I knew one of the legs was 11, one of the angles was 57. I can figure out the other angle. I can figure out the hypotenuse using trig. I can find the opposite side. I'm not going to do that right now, but I can find the opposite side using tangent, or I could use the Pythagorean theorem now that I know the two sides. So put all this piece of information together and figure everything out if you need to. Okay, here's another pretty different problem. That was one, so what we just did was we found missing sides when we knew an angle and when we knew one side. Now I've got a triangle and I don't know any angles, but I know two sides. I could find the hypotenuse using the Pythagorean theorem. But what about if I wanted to know what the measure of, let's say, angle A was? Okay, I can write another ratio. 5 divided by 13 is equal to the tangent. All right, that's the opposite is 5 and the adjacent is 13. That's opposite over adjacent is the tangent of angle A if I'm standing over here, right there. Tangent of A. Okay, well, so I want to know what angle has its tangent value opposite over adjacent. What angle has that tangent ratio? It's a unique angle. Every angle has its own tangent value, its own sine value, and own cosine value. It's a fingerprint for that angle in a right triangle. Okay, well, the way you write this down is the inverse, or the way of undoing, taking the tangent, is to take what's called the inverse tangent. And on your calculator, it looks like it's got a -1, but it's not an exponent. It just means inverse. So you write it down like this: the inverse tangent, and you say the inverse tangent of 5/13 is equal to angle A. And I'm going to write this down in a sentence. It says, this is asking the question, what angle, this is what this means, what angle has an opposite over adjacent ratio of 5/13. That's what that tells you. And on your calculator, luckily, we have a button for that. Some of you might have different calculators. You might have to ask me or get some help figuring out where these buttons are, but hopefully it'll be clear to you. But I do. Tangent, inverse tangent of 5 divided by 13, and that tells me an angle. That angle A, is equal to, I can't remember what it was, 21.4, 21.04 degrees. I can find angle B two different ways. I can say the tangent of angle B is equal to 13/5, and again do inverse tangent of 13/5 equals B, angle B. I'll put the angle symbol in there, and I do that. And the inverse tangent of 13 divided by 5 is 68.96. Angle B is equal to 68.96. Now, what should be true about angle A and angle B? Well, they are acute angles in a right triangle. They should be complementary. Let's see if that works. 21.04 is the way I rounded it off, plus 68.96. Does that, yay, that adds up to 90. So the other way I could have found angle B is I could have done subtraction in the first place to find out that it equals 68.96, and I could have used tangent to check it. So all these things fit together. You should definitely explore different ways of how things fit together. That is the end of this podcast.